So in our ordinary experience, we think there are 3 spatial dimensions and 1 time dimension, and that seems very real to us. But what the quantum mechanics of black holes seems to be telling us is that actually one of those dimensions isn't really there. It's an illusion, but it's a very good illusion. My name is Daniel Harlow. I work on black holes and quantum gravity at the Center for Theoretical Physics.
My name is Aram Harrow, and I'm in the Center for Theoretical Physics. My work is on quantum computing and quantum information. I'm a theorist, so I ask questions like, what would we do with a quantum computer if we had one? I'm not one of the people who tries to build a quantum computer. So I really like Daniel's work, and I've been following it from a distance with interest for some time. We haven't actually spent much time in the same place at the same time, and I'm really looking forward to talking to him a lot more in person, learning from him, and finding some way to contribute to the problems that he works on. There's a lot of crosstalk with other faculty at the CTP. And one amazing thing that's come out of Daniel's work on quantum gravity has been this connection with quantum error correcting codes. Quantum error correcting codes turn out to be a way that we've evolved a sophisticated vocabulary of how information can be encoded in non-local ways. So not just the information is here or there, but the information is spread out across these systems such that it's accessible if you can measure this subset, but not accessible if you measure that subset. That's something that we had developed in the quantum computing community for the goals of building quantum computers out of reliable parts, and turns out to be applicable to some of these problems in quantum gravity, as people like Daniel have worked out.
What the quantum mechanics of black holes seems to be telling us is that actually the mathematics of that quantum error correction seem to be the same kind of mathematics that allowed a 2-dimensional theory to pretend to be a 3-dimensional theory. And you look at this tree, and what's happening in those seemingly 3 spatial dimensions can really be described only using degrees of freedom that live in 2 spatial dimensions. Physical stuff is different. One is a quantum computer, and the other is quantum gravity with black holes, but the software that it's running is the same.
What I find really thrilling about this connection is that quantum error correction codes sound almost like an engineering trick. And the work of Daniel and others on connecting to quantum gravity shows that they're actually expressing something pretty deep about the nature of quantum information.
One very nice thing about the Center for Theoretical Physics is that there are people working on nuclear physics, quantum information theory, dark matter, string theory, quantum field theory, working on condensed matter physics. And the state that theoretical physics is in currently is that the boundaries are not so clear as they used to be. We're constantly using tools from other branches of theoretical physics. So there has been this flow of information back and forth, and we really treasure that, especially in a place like CTP where there's no directives that come down from on high about you should be working on this or you should be working on that, or why haven't you written a paper about this yet. You know, it's really just, it's up to you. You can build what you want. You can talk to whomever you want to talk to. You can work on whatever you think is interesting. And that kind of environment, I think, is really special. It really enables us to do things that contribute, well, they're fun, of course, but they also contribute to society in a long-term way. And it's nice to be a part of it.